Okay, so we're gonna start inductive reasoning. Okay, so this is the part of geometry where it goes away from numbers and things like that, and we're gonna start doing sentences.
Yes.
I don't like speaking
We are going to talk about inductive and deductive reasoning today, okay? And we're going to spend some time on this. We might spend a few days on doing different things. Inductive reasoning, or simply induction, is a way to decide if something is true or false. Your conclusion is what inductive reasoning is based off of. Guys, you do this all the time in science. Do you make, you look at data and then you make conclusions off of it, you use hypotheses, yes? Okay, we're gonna start applying that to this. Geometry has lots of logic in it, and this is the beginning of
I
that.
took logic class.
Yeah, you'll be good at this.
Yay!
I don't have logic.
I still have my logic book.
So, this is where geometry, this is going to set us up to start doing proofs.
I still have Proof's PowerPoint
No, I don't want.
on Power School. Proof's PowerPoint.
Mm-hmm. Okay, so we're gonna talk about inductive and deductive reasoning. Okay, so let's take a look at something, because we will have some numbers here. Let's say we have these patterns, okay? Find the next number in each pattern. In order to find the next number in each pattern, you have to use some inductive reasoning,
Oh yeah.
okay? 3, 4, 6, 9, 13, what comes next? Why do you say 18?
Because it increases by 1, 2, 3, 4, 5.
That's not.
6.
I love this one. There you go.
So,
Yes, it is. My favorite lesson.
it wouldn't be, if you're thinking it increases by 6, is that what you're saying?
No, I'm saying increases by 5.
Proof's by
Oh,
five.
it increases by 5, okay, yeah. So
Okay.
it's
Which one?
the first one. It
3,
goes,
4, 6.
it increases by 1 between 3 and 4. Between 4 and 6,
Three.
it's 2.
Oh, okay.
Four.
Sorry.
5,
I thought you were saying increases by 5 each time.
yep, so then you get 18, okay? What about in the next one, 0, 1,
25.
4, 9, 16?
1.
What?
25.
But
Oh,
what's
it
the
increased by
pattern?
9. It would be 20,
1,
20, 25.
1, 3, 5, 7.
I said, what's the pattern?
It goes plus
Odd number.
0
Plus
plus 1.
two.
It's like odd number.
Every time. They add the odd. Wait,
I
plus
don't
2
get that.
from each odd number.
Ashley?
It's like that. A minus 1 plus. How would you guys say it was?
Minus 1 plus 4.
No, what she's saying is, if you subtract,
It's
Um,
equal
the-
less than.
yeah, if you subtract the number, okay, so look at this. If the first entry, is 0, and the second entry is 1, and the third entry is 4. If I take, what's 4 minus the entry before it?
3.
3, what's 3 squared?
9.
That's how you get the
One.
next one.
Whoa.
So it's-
9 minus.
Run that back.
So it's the number minus 1 and then squared.
It'd
still be
25
9 minus 4 is what?
5.
5 squared is?
5.
Yeah, so then so it goes like this. There's several different ways to look at it. So this one leads to that pattern, and that one leads to the next one. This is 1 squared is 1, 2 squared is 4, 3 squared is
Oh, is that?
9, 4
it's
squared
okay. I
is
never read
Next
that.
one's 36.
5 squared. You have to be able to identify the pattern for me, okay? 5 squared is next, 6 squared would be after that, 7 squared, 8 squared, 9
I've seen 2
What?
teachers put shoes on.
So, I know last year we had to do something like this. We had to we had this whole formula and everything for it. But with this, do we just have to think about it and then write it down?
Yes.
Okay,
So
awesome.
Well,
No,
not
that
yet.
was a different thing.
When
That
we
was
get-
like finding a term that's
Yeah,
Yeah, that's,
Yeah.
that you'll do in algebra
But
2
that's
again.
term.
It was you
Still
you
part-
identify
it's still
the
part of it.
We'll do that,
you identify the pattern and then you plug in the number that you want to find.
okay? What is the pattern in the difference between the squares of numbers?
It's that times itself.
What is the pattern in the difference between the squares of numbers?
Oh.
Some number after it's squared.
So if you have 2, what's 2 squared?
4.
If you have 3 squared is?
9.
Oh, it's the top number.
4 squared is 16. So what is the pattern in the difference between the squares of
X.
numbers. 16 minus 9 is,
7.
9 minus 4 is,
5.
4 minus 1 is,
3.
what's the pattern?
Decrease by 1
It's like by 2. It's like
11.
it's 1 plus 1 plus 3 is 4.
47.
4 plus 5 is 9. And 9 plus 9 is 16. So it's plus 2 plus 2.
Now, what would be next here?
Well, this doesn't make
25.
sense.
9.
What? I don't get it.
So they're saying, what is the difference? What is the pattern in the difference between the squares of numbers? So 4 squared is 16, 3 squared is 9. The difference between those would be 16 minus 9, which is,
7.
okay? The difference between 3
Oh,
squared
it's
and
odd
2 squared.
numbers.
Yes, it's odd numbers,
Okay.
3, 5, 7, 9.
So the answer's odd number.
So the answer would be odd, it increases by the odd number.
Odd.
I'm gonna be bad at this.
Okay?
You have no logic
Chloe,
whatsoever.
let's go. You got this.
You're not gonna be bad at this.
Chloe, we got this.
Chloe, you got it.
Anything.
Let's use
Let's
your
be
brain.
bad
You'll
at
be good.
things.
Okay, now look at this. What do you notice between here?
2.
2.
2.
Bro.
We'll get to that
0.
later.
0.
It has something to do with
Yes.
Pascal's triangle.
Yeah.
If you wanna go to 0, you go until all the numbers are the same.
What?
It's Pascal's triangle. 1, 2, 3, it's a third
Pascal
order.
Isn't that
from
Pascal
Tangled?
from Tangled?
Y'all stole that from me.
We were all thinking it, Abby.
No.
I was thinking it.
Okay,
I thought it in my
No,
brain.
you can't.
some more vocab terms.
Actually, don't, because I can make.
A fractal. A fractal is a pattern that is repeated at every scale. So that if you zoom in, you are seeing the same pattern you would see at a distance,
That does not make sense.
like this.
When you, it's like never ends.
If I have something like this.
Acts at every scale. That's not proper grammar, I don't think. A pattern that is repeated at every
Repeated.
scale.
Repeated.
It should be repeated at every scale.
Excuse me. Ooh,
Is it like a?
okay.
Oh wait. It's like Sauron from Lord of the Rings. When you go into like his eyes, there's another one.
Yes,
And then
What?
Oh, yeah.
yes.
What's
You,
Lord of the Rings?
That's Hobbit too.
You
What?
unclick my
What?
swine. Never ending.
What?
What are the rings?
How do you not?
I know what it is, but what's it about?
It's about.
Myths.
Oh my
Oh,
goodness.
no.
you're gonna pretend that my drawing is.
I'm about to go on
okay.
to an entire Lord of the Rings rant.
You should watch that scene. That seems actually
Never
pretty weird though.
ending.
Isn't it like
At the very beginning.
Okay.
No, there are wizards.
So
It's like-
so it's like as you zoom in, you're gonna keep seeing the same pattern. So I zoom in to this, or if I like zoomed out of that, I would get this, and if I zoom out, I would get that.
They're like trying to.
So as you zoom in, you see the same pattern repeating that makes up that whole picture,
That's cool.
okay? A conjuncture, juncture.
What's not function?
I know, but I'm changing this.
Well, that's a memory word.
Okay, conjuncture is a conclusion reached by inductive reasoning. It remains to be proven true. Meaning, it is not a true statement, you have to prove it. It could be a true statement, but you have to prove it. It's not something we accept as true. A counterexample is an example that proves a conjuncture is false. Okay, I have another way of looking at this. So here's the deal. For instance, perhaps someone says, all odd numbers are prime. 3 is prime, 5 and 7 are prime, okay? You see all numbers are prime. That would be my conjuncture. Okay? Is that true? Give me a counterexample. What?
9.
Good.
Oh, wait, say what you were saying again, I'm sorry, I was ready.
So if someone says all all odd numbers are prime. For example, 3, 5, 7 are prime numbers. So therefore, all prime numbers,
Oh, the nine.
9 is your counterexample.
Yeah.
Okay? So when you're giving a counterexample, you're giving something to make that statement false.
121.
Okay? Yeah, I mean, you could have picked anything, but
Yeah.
a lot of numbers, but yes. Okay? So that is the type of stuff you are working on tonight. I want to still show you. Something else.
In her head, she said 999.
I need my pink pen. I can't find my pink
Okay,
pen.
so just another way to look at this would be, this is written in paragraph form, a couple of them. Inductive reasoning, we can go from observations to a general conclusion. A conclusion is drawn using inductive reasoning, aims at probability, not certainty, okay? And the inductive reasoning can result to a true conclusion even if the premise of the statements are, true. Even if all the premises in the statement are true, okay? Inductive reasoning does not guarantee the conclusion to be logically correct. We'll talk about inductive some more tomorrow, okay?
This looks like one of those things that
We're
we
good.
get on my shirt.
Inductive reasoning does not guarantee the conclusion to be logically correct. John leaves for school at 7 a.m., John reaches school on time. John assumes that if he leaves at 7 a.m., he always reaches school on time. This statement is an example of inductive reasoning, okay? Because when he left at 7, he got there on time. So you would say, oh, okay, I can get there on time. The drawback of inductive reasoning is its failure in supporting conclusions drawn with real life scenarios. Because what could happen? Could he be late, traffic, a wreck, anything like that, okay? So even though you can do that, there can be some downfall to it, okay?
Complete the like giant. We're doing minute left.
We will talk about deductive reasoning also later in this chapter, but I'm gonna just give you a little bit of an example of it. In deductive reasoning, a statement is known or assumed to be true, and other statements are deduced from it. So when you have deductive reasoning, it's saying, here's a statement that's true, now pull from that statement other things that are true. Okay? So inductive, we have to prove is true. Deductive, we know is true. Okay? The statements concluded using deductive reasoning will always be true if the given statement is a well-known true statement. We'll talk about that. This is later in the chapter. The deduced statement is not based on the observation since the given statement is already known or assumed to be true. So it's not based off of observation. It's simply true because the original thing was true. Okay? All men are mortal. Tim is a man, so he is mortal. This is an example of deductive reasoning.
Oh, very nice.
If the given statement is assumed to be true, then the statements deduced are not necessarily true. And we'll talk about that more later. But today you're focusing on inductive reasoning, which means you have to prove that it's true. And you're focusing on patterns. So your homework's gonna have inductive reasoning and patterns in it, and that's all. Okay? Abigail. Bye, friends.
Bye.
Thanks for watching, guys.